In this example, for using audio in Android applications, we've created a simple soundboard application. The app will present a grid of animal names, and when one is pressed, it will play a corresponding sound for that resource. First, let's take a look at our project structure. We see in our resources directory, we have a folder called raw. This is the location for arbitrary files to save in the raw form. To open these resources with a raw input stream, you can call resources open raw resource with the resource ID, which is r.raw. The file name of the raw resource file. We will see shortly that we have convenience methods for loading these files and for later playing the sounds from our sound pool player. Let's take a look at the main layout for this application, the activity main.xml. Our main activity consists of a grid view with ID GVAnimals. The animal names are stored in our strings XML and will be loaded to the adapter for this grid view. Let's jump over to the Java code in our main activity.java. Our main activity contains a constant for the max number of audio streams. This will be relevant with our member variable mSoundPool, which is a sound pool that will allow us to play audio sounds in this application. In our onCreate, we initialize our sound pool and the grid view with our animal grid adapter. Then we set an on-item click listener for our grid view to the same adapter so that it can handle all of the logic and other aspects of loading and playing the sounds. Now let's take a look at the method for initializing our sound pool. When we initialize our sound pool, it is important to determine what version of Android is currently running. This can be accomplished by accessing the constant build.version.sdkint. If it is equal to or greater than build.version codes lollipop, then we will initialize the sound pool with the new sound pool builder class. In case of a previous version, then we will use the now deprecated constructor for sound pool. Once the sound pool is initialized with the max number of streams, and with the stream type of music, we load the sounds for our application, our adapter, by passing it the sound pool and a context reference. Let's take a look now at our adapter and how we initialize and play the sounds for our application. In our animal grid adapter, we have a constant for the array of our sounds to play by listing all of the resource names to play the different animal sounds, which we will map to the items in our grid view. We also have a string array of the labels for each item, which we'll initialize in our constructor. There are also the member variables of a layout inflator, a sound pool, and a map of our sound IDs. Now let's look at the constructor. In our constructor, we get the string labels for our animal sounds from our resources by calling on the context getResources, getStringArray, and the name of the string array. We then set that to our static variable item labels. We also receive a layout inflator as a parameter and save that to our variables and initialize our sound ID map by calling a constructor and a new instance for the new hash map with two integers as the parameters. In our getCount method, we return the length of the item labels, and that will be the number of items we have in this list. It is important to note that the resources and the files in our raw folder are synchronized for proper running, so that if anything changes, those items will have to be resynchronized with the strings in the list and our resources files. Now let's take a look at our getView method callback. In our getView method, we inflate our convert view, if null, to the Android resource simple_list_item1, which simply contains a text view with the ID text1 from the Android default resources. We set the label to this text view and return the convert view. Now let's take a look at the load sounds function. Now in the load sounds method, when we call from our activity, once a sound pool has been initialized, we first save our sound pool for later playing of sounds, and then we run over the array of the sound resources and load each one into the sound pool. When we call the load method on our sound pool, it will return an integer, which is the ID for that sound, so that can be played later. We store these IDs in our sound map hash according to their position in the list. That way, on the item click, we can play the appropriate sound according to its sound ID, which we had stored in the map. The sound pool will take care of the rest for us and play the sound on a device or on an emulator. So let's run the application on the emulator and see how this code runs. We see here we have the grid of the different animal names that we have listed in our array in our strings XML. Each one of these names will be associated with one of the raw WAV files of that different animal. So for instance, if we click the lion name, we can hear the sound of the lion WAV file. As opposed to if we click the cat name here, it will call the associated cat WAV file. Thank you for joining us in this example for audio and Android. Next, we will take a look at examples of utilizing video in Android application development. In this example of using video in Android, we've created a simple project that will display a video and allow the user to control it through custom controls that we have added to the UI for this activity. Let's start with the UI for our main and single activity for this application with the activity main XML. The UI for our main activity has a relative layout with a top child of a horizontal linear layout, which contains 3 buttons. A play button, which has a callback to the method play video, a pause button, which is a callback to the method pause video, and a stop button with a callback to the method in our main activity of stop video. We will take a look at all of those callbacks shortly. But now let's look below the linear layout. We see we have a video view object, which is listed to be below the controls or the linear layout containing those buttons. And this video view has the ID of VV video. Now let's jump over to the Java code for this activity and see how the method callbacks and the rest of our code is implemented. In our main activity, we have a constant for the URI for our video file, which is stored in the raw resources directory. We also have a boolean for if the video has already been initialized, and a video view variable for playing the video later on, and also pausing and stopping our video. In our onCreate, we get the video view from our UI and initialize the video according to the URI for our local resources raw file. We also set the initialized boolean to true, so we know that the video has been initialized with setting the URI. In our play video method, we check if the video has already been initialized. If not, we set the video URI and ensure to initialize the video to it. We also set the initialized boolean to true. Then we start the video by calling the start method on the video view. In a similar fashion, in the pause callback, we check if the video is playing. If it is not playing, we simply return. If the video is playing, then we call the pause method on our video view. In the stop video method, we call the suspend method in order to stop the video and also release some of the assets. This call will release the video, which means it will reset and release the media player the video view is holding. It will also set the video view current state to idle. Finally, note that in our onPause activity method callback, we call the stop video method. This will ensure that we will release all assets that we need when our activity goes to onPause. Now let's run the application on an actual device, since emulators have trouble playing back video, and see how it runs. Here we see a video taken from the ADB record video option we have shown previously through Android Studio. In this screen, we press the play button on our actual device, and the video begins to play. Then when the pause button is pressed, our video will pause, and when the play button is pressed again, the video resumes. We'll see shortly that we'll arrive at the second slide in our video. When we arrive at the second slide, we press the stop button, and our video is stopped. Then pressing the play button, we'll start our video again from the beginning. Thank you for joining us in this video on how to implement video in Android. Please join us in our next video where we'll cover the lab exercise for this section.